Hi and welcome to Geeks for Geeks. Today we would be doing the post contest analysis of GFG Weekly Coding Contest 90. So, can I have a quick yes or no that yes, you are present and we can just move forward? So, question 3, logic. Okay, so let's talk about questions were not at all clear. Okay, so let's talk about the contest first. So, if I see on the contest, the very first problem was a brute force problem. And to know that yes, this is a brute force, you can just write it down in a pen and paper. And when you come to the conclusion that yes, this can be this thing, then it was evident. But the problem statement, in terms of a easy person, was a little bit difficult. Like you need to just, when you want to just know the single problem, the problem number of lines in that problem were big and the explanation was very big but still not clear. So just when you write it down, then it becomes clear. Let's talk about the second problem. Will the student pass or not? So in this problem, this was a little bit difficult on the medium side. Like this sat on the medium side, and you already knew about bitwise and you saw the constraint, then obviously you were good to go. Let's talk about the very third problem. The third problem had weak test cases. If you had submitted a n square solution, it would have passed. Okay. And the easy one, okay, like the third one and the optimal solution was a mix of all the beginner based algorithms. So if you, unlike, the problem statements were a little bit difficult, but the problems were good if you just see this explanation. Okay, like if you just understand the problem, after understanding the problem looks beautiful, to be honest. Okay, like questions were not clearly explained, I understand, but the problems were great. Like if you just jot down the problem that yes, this is the problem, then sir, it did not pass for O n square. No, I would just code and then show you that yes, it would pass for O n square. Okay, so I think we are good to go. Let's start. Okay, good enough. Now let's talk about the very first problem. Okay, so I think you have already read about the problem statement, so I won't tell you that please read the problem statement again, because you would be frustrated and I would get a very low rating among this. Okay, so let me explain you the problem this time. Okay, so now see, if I just see this problem is somewhat like this. It is told that there are three bowls. Let's say three bowls. This is the very first bowl, and this is the second bowl, and this is the third bowl. Okay. Now, what you need to do is the two bowls would be swapped among them. Two bowls would be swapped among them. Okay. If two bowls are swapped, then after that you need to guess that which, like there are two bowls. Okay, let me just tell you. This is the first bowl, this is the second bowl, this is the third bowl. And in there, a ball is kept. Okay, ball is kept. Basically, this is a bowl, so you won't be able to see the ball. Okay, like let me just draw the bowl itself. Okay, so this is not visible. This is not visible. Okay, so now suppose I know that the ball is under the two, but no one other knows. So now we would just juggle this up. What do you mean by juggle? So what would happen is that this thing would come here and this thing would go here. Okay, then what is the use of juggle? The use of juggle is that earlier the place of this bowl was here. So after picking up the ball and keeping it here, then keeping up the ball, keeping it here, the ball retains its position, only the cups change. ट्रांसलेटिंग द सेम इन हिंदी इज, दो कप रहेंगे, ओके, दो ऐसे कप रहेंगे और यहाँ पे बॉल रहेगा। सो कप उठा के यहाँ कर दिए, ये वाला कप उठा के यहाँ कर दिए, बट बॉल अपना पोजीशन पे रहा। दिस इज व्हाट यू नीड टू अंडरस्टैंड, ओके। Am I clear with the problem statement? Like, what is juggling? The position of the ball is retained even if it is swapped. Okay, so after that, it is a very common procedure that after juggling is done, you need to just guess the ball is under which bowl. Okay, so you say that it is two, then you got a wrong answer. You say it is one, then you got a right answer. So am I clear with the problem statement or not? That there are three balls, one, two, three, and we would juggle those ball, and the ball would retain its position. Only the position of the ball would change. Please keep this in mind. Ball का जगह वही रहेगा, only glass का जगह बदलेगा. Am I clear? Give me a quick yes or no. So screen is not visible. Stop sharing. Screen was not visible. Okay. I need to just draw it again. Okay. So see, I would draw just again. This was what was my drawing. So now let's draw this again. No issues. Okay. बस अच्छा comment मिल जाए. I'm not issued with this. Okay. So see, suppose there are three balls. Okay. Fair enough. Suppose there is three ball and this ball is kept at this. So, and we are told that this is bowl 1, this is bowl 2, this is bowl 3. Let's take glasses. Okay. So now we are given three glasses and we are given a ball under a particular glass. Okay. After this, what happens is two glass is juggled. What do you mean by juggled? Let's suppose say that 1 and 2 is juggled. If 1 and 2 is juggled, then the ball would remain at its position. Only one would come here and two would come here. So before the ball was inside below one, now the ball is below. Earlier the ball was below two. Now the ball is below one. The ball would retain its position. Only glass would change. जब juggling होगा तब क्या होगा, ग्लास यहां से यहां आएगा बट नीचे वाला बॉल यहाँ का यहाँ ही रहेगा. यही एक जगलिंग का पार्ट है. The ball would retain its position, only the glass would change. So am I clear? Like what is this juggling method? What is this? What is the whole setup? Like we are given three glasses, we are named as one, two, three, and we are given this. Am I clear with this? Give me a quick yes or no. Give me a quick yes or no if this thing is clear. Clear? What about others? There are 41 live viewers at this point. Can you quickly tell me? Okay, thanks a lot. Okay, fair enough. Now we would move forward. Now, in this question, you are told that you are told that you are given a ball and you need to select its position. Like it is to be kept in inside the first bowl, it is to be kept inside the third bowl, it is kept to be inside the first bowl. So decide the initial position. Decide the first position. Okay, this is the very first thing you need to do. Now what is the next thing? Now there is a proper array given. The array is given in the form of A, B and P. What do you mean by A, B and P? A means, suppose A is given as 2 and B is given as 1, and after that it is predicted, suppose let's say 3. Okay, so AB means that A and B is juggled. A and B is the juggling one. So A, so 2 and 1 is to be juggled, so 2 would come here 1, 2 would come here, 1 would come here, and it would be. After this, we are predicting that the ball is inside 3. Is ball inside 3? No. So we would get a wrong answer for this. Okay, this is the array that is given. Now what you need to do is, you need to decide the initial position of the ball. Okay, then you are given number of jugglings and prediction, and you need to tell that keeping the ball under which glass is the most suitable to win the prediction. ट्रांसलेटिंग द सेम इन हिंदी वुड बी, हमें ये बताना है कि सबसे पहला बॉल 1 के नीचे रखे, 2 के नीचे रखे कि 3 के नीचे रखे। उसके बाद ए और बी में जगलिंग होगा और प्रेडिक्शन होगा। हमें ये बताना है कि कौन सा सबसे ज्यादा फायदा देगा कि हमारा प्रेडिक्शन सही हो। ओके, सो नाउ लेट अस मूव फॉरवर्ड। ओके, so let's talk about the very first sample test case. Okay, so it is given at this point. Okay, the answer is 1. So let's draw the same thing. Okay, let's not draw the same thing, let's copy the same thing. Okay, suppose this is what it is given. Okay, I would remove this annotation. Yes, so it is told that if we keep the ball under 1, we would win 3 times. Let's first test it if it is correct or not. Okay, let's first test it. So we would keep the ball under 1. Let's first keep it. Then it is told that we would first juggle 3 and 1. 3 and 1. So first we would juggle 3 and 1. So 3, 1 would come here, 3 would take its position, and 1 would come here. After that, we are predicting that the ball is under 2. This is the prediction. Okay, ball is under 2. No, ball is not under 2. So here we are getting a wrong answer. So from this is not correct. Then we are again juggling 3 and 2. Let us juggle 3 and 2. Let's take 3 here. Let's take 2 here. And let's take 3 again at back. And then we are saying that 1 is the position where the ball is there. 1 is the position. No, 1 doesn't have any ball. So this also contributes 0 to us. Then we are again telling that 3 and 2 is again juggled. So 3 would come here, 2 would come here, and again 3 would come here. Okay, and then we are predicting that yes, the ball is under 3. Yes, the ball is under 3. So this would contribute 1 to us. Then again we are telling that we are juggling 1 and 2. Okay, we are juggling 1 and 2. Let's juggle 1 and 2. And we are telling that the ball is under 3. Yes, the ball is under 3. So it is correct. Then we are again juggling 3 and 2. So where is 3? 3 is here. Sorry. Okay, I messed this up. Okay, let's have it like this only. 1, 2, and 3. First, we would keep the ball here. Let's just have it like this so that I don't create any confusion. So first, we are telling that 3 and 1 is to be juggled. So 1 becomes 3 and 3 becomes 1. We are juggling this. Okay, 1 becomes 3 and 3 becomes 1. Okay, and then we are telling 2 has the ball. Does 2 has the ball? No, 2 does not have the ball. Okay, am I visible? Yes, I'm visible. Okay, then I would say 3 and 2 is to be juggled. So this would become 3 would become 2 and 2 would become 3. Okay, but the ball would remain at its position. The ball is under 1. No, the ball is not under 1. So this is 0. The ball is not under 1. Then 3 and 2 is again juggled. 3 and 2 is again juggled. So 2 would become 3, 3 would become 2. And then we are saying that the ball is under 3. Yes, the ball is under 3, so this would contribute 1. Then we are again juggling 1 and 2. We are again juggling 1 and 2. So 2 would become 1 and 1 would become 2. And then we are predicting that the ball is under the 3. Yes, the ball is under 3. Then we are again juggling 2 and 3. Let's do this. This is 2. This is 3. We're just swapping the values. Okay. The ball is under 3. No, the ball is not under 3. Then we are again juggling 1 and 3. Okay. Then we are again juggling 1 and 3. Okay. So 1 would become 3 and 3 would become 1. And we are saying the ball is under 2. Yes, the ball is under 2. So 1. So 3 times we were correct in our prediction. That is why if we keep the initial position of the ball under 3, we would win 3 times. Am I correct? Just give me a quick yes or no. That are you able to understand the problem statement or not? Just give me a quick yes or no. Am I clear with the problem statement? Like how this answer for 1 is 3. Okay. Chalo. Okay. Now let's move back. Now, yes. Thanks. Okay. Now let's go back. Okay. So now we can see that what we need to do, basically what we need to do. So let's first understand that if suppose there are 1 and 2 and the ball is at this position. Okay, let's suppose there are only let's as of now let's keep 3 here. Okay, let's first, this is 1, this is 2 and this is 3, and let's keep the ball at this position. Okay, let's keep the ball at this position. Now the ball, current position of the ball, so ball position is equals to 2. Okay, and if a is equal to 1 and b is equal to 2, suppose the ball position is at 2 and a is equals to 1 and b is equals to 2. If this is the condition, then when it is juggled, what happens basically? When it is juggled, if ball position is 2, if b is equal to ball's position, if b is equals to ball's position, if b, like let's take the first condition. Okay, if b is equal to ball's position, if b is the ball's position, then after the juggling, after the swapping, ball's position would become a. If the opposite, if a is equals to ball's position, then after juggling, ball's position would be b. Like suppose there is a and b, just remove this, just remove this. This is a and this is b. So after juggling, if earlier the ball was under the a, after juggling it would come under a. Okay, if before juggling the ball is under b, then after juggling the ball would be under a. In the same manner, if before juggling the ball is under A, then after juggling the ball would come under B. So I'm telling the same thing. If B is the ball's position, then after juggling this would be the position, and same goes for this, the vice versa of this. So am I clear with this condition or not? Like what happens in the process of juggling? In the process of juggling, If B is equals to ball's position, then it becomes A. If A is equals to ball's position, then it would become B. Am I correct? Just give me a quick yes or no. Should we keep ball under 3 only? So am I correct? Just give me a quick yes. Like I'm just what I want you to what I want me to convey to you is I want you to understand the process of juggling, like what happens in the process of juggling. Okay, I'm clear till this point. So now let's say that there are three positions. Okay, this is position 1, this is position 3, and this is position 2, this is position 3. There are three positions only, and initially the ball can be kept under 1, the ball can be kept under 2, the ball can be kept under 3. So what we can do is we can keep the ball under all of 3. Keep, like there are three options only. Keep the ball under 1 as well as 2 as well as 3, and the maximum output which is giving us, it would be the answer. Keep the ball under this. Okay, let's start the coding part and then you would understand. Please keep this thing in memory. Please keep this thing in memory. Problem question statements, Niket Dahula. Okay, so I would explain again. So see, just see. Okay, so now see what happens. Suppose there is a glass kind of structure. Okay, this is glass A, this is glass B, and here a ball is kept. Okay, here ball is kept. Now, earlier the position of the ball was B. So if we swap this, then after swapping, if earlier position was B, then the current position would be A. So this is what I'm telling. If earlier position is B, then current position would be A. Okay. In the same way, the opposite of it, if earlier position was A, it would become B. If we are to swap, like juggle between A and B, juggle A comma B, if we are to do this. Okay. Am I clear to you, Niket Daula? Just give me a quick yes or no. Give me a quick yes or no if I'm clear to you, Niket Daula. I'm waiting for you. Okay. So now I think in real life, okay, thanks a lot. Okay, now I would present the tab itself, Chrome tab. So juggling. Okay, I'm very lazy person. So we would design a function, okay, which would tell me the count of how many points we can achieve if we keep the ball under this. So the return type point would be in integer form, and the name would be rex, and we would pass this array also. Okay, we would pass this array, and then we would say that this is the current position. Like from this position we would start. Current position is equals to this position we would start. This would be the initial position. So total points, initial total point, the scoreboard would start from 0. So it starts from 0. Now for auto v dash a, okay, for auto v dash a, we would iterate on all the values. So now we would say there are given three values, a, b, and p. So int a is equals to v dash 0, v is equals to v dash 1, and E is equals to V dash 2. Okay. Now we would first juggle this. So if A is equals to the current value, then current value would become V. I said you this, that after swapping, the ball would get swapped with this value. Okay. Else if B is equal to, if the ball is under B, if the ball is under B, then after juggling, if the ball is under the B, then after juggling, the ball would be under A. And now we would say after juggling, we know that what is the current position of the ball. So if the current position of the ball is equals to the prediction that is made by us, then we would increment the answer and say, yes, this prediction was correct. You got a reward of 1. After that, we would just return the answer that this is the answer if we start with the current. Okay. Now, here what we would do is, here we would say that the maximum times we can win, the maximum value, like we need to find the maximum times we can win. No? So initially, max is equals to 0, and this is the value. Okay. Now we would start from the very first one. Like we would first keep the ball under A, then 2, then 3. So int I is equals to 1, I is less than 4, or I is less than equal to the value 3 and I plus plus. Okay. So now we would say that rec of, this is the array itself that is already there. If let's keep the ball under I. If keeping the ball under I, the points gained is more than what we have right now, then mx would be equal to rec of a of I, comma I. Okay, and the value would also increase. That yes, at this value we would get rec of I. Okay, fair enough. At the end, we need to return the value and the maximum point. So we would return value and the maximum times we can win. Simple enough. Now let us see how many mistakes are we making. Okay. So rec of A of I. No, rec of A of I won't be there. Rec of A would be there. Okay. Correct. So now tell me the line number at which you are not able to understand. Okay. Till then, let me just show you what this is happening. Okay. So I would stop sharing this. I would share my whole screen itself. Let me do, okay. Let's just do the dry run of this because earlier people were confused with the dry run. So let's first say that 3, 1 and 2. The ball is, the current is equals to 2. Now let's suppose that we need to juggle 1 and 2. Okay. So if we need to juggle 1 and 2, okay, then the current position of the ball, like this is the position of the ball. After juggling, 1 would come here. So the current position would increase. Okay. The current position would be there. After that, we just check if the current position of the ball is clear to the prediction or not. If the current position of the ball is equal to the prediction, then yes, we got a new point. This is what is happening at this point. So give me a quick yes if this thing is clear. Give me a quick yes. Give me a quick 1 if this thing is clear, and so that we can just move forward. Question is very confusing. In real life, even the ball would move along with the grasses. Yes. To be honest, this is true. The ball would move along the glasses in real life, but we can't really help with that. Like the position of the ball is retained. I never saw juggling in that form. Okay, I think we can move forward to the next question. So, what is your next question? Can you tell me the name of the question? Thanks a lot. So, can you increase the number of likes in the video? Till then, just let me know the name of the next question. Can you tell me the name of the next question quickly? Name of the next question. I am bound to explain you the second question. So just tell me the name of the second question. Okay, let me just see in parallel. The name of the second question is what? Let me just see. Will student pass? Yes. Okay. So now let's go back at this point. And will the student pass or not? This is a very interesting problem. Okay. So in this problem, to be honest, it seems a bit confusing. Okay, but I would help you. Don't worry. Okay. It is told that I have n courses. It is told that I have n courses. Let's just remove this. So it is told at this point, I have n courses. So suppose the value of n is 1, 2, 3, 4. Suppose I have 3 courses. Okay. Let's say I have 3 courses. 1, 2, and 3. Okay, I have 3 courses. It is told that a person has n courses and he wants each student to gain X amount of knowledge to pass. Okay, and he wants the knowledge of each student. He wants the knowledge, okay, knowledge of each student greater than the value X. Okay, he wants the knowledge or the points gained out of each student is greater than X. Okay, and he also tells that if the ith person is reading jth, okay, like if a of I, like a of 2, 3, okay, this just means that this person, third person knowledge, third person's marks, let's say marks from second course, like the third, like if the third person buys the second course, then he would get a knowledge of A23. Okay, it is told like this. And each A of I, like each course has a price. Okay, now he wants to have each person at least X number of knowledge. Okay, and if there are multiple ways, then obviously he would tell that what is the minimum amount to be spent. Okay, translating the same in Hindi would be that, see, एक course से, so from a single course I can get more benefit than someone else, or someone else can get more benefit than me. It is very similar to real life. So now we are telling that there are n courses and each person would be getting a knowledge of something if he buys that course. So if the third person buys second course, then he would be getting a knowledge of this. If the fourth person buys third course, then he would be getting a knowledge of A34. Like in the array, we would given a 2D array and we can go to the 3, 4 index, and then you can row number 3, column number 4, then that would be the knowledge. And out of that, you need to find it. So basically, you need to sell few courses to few people. Okay, this is what is the problem. n कोर्सेज दिए गए हैं, ओके, n कोर्सेज दिए गए हैं, और हमें ये बताया जा रहा है कि आप एक स्टूडेंट को कोर्स दो, ओके, वो एक स्टूडेंट हर कोर्स से अलग अलग नॉलेज लेगा, और ईच स्टूडेंट को एक्स अमाउंट ऑफ नॉलेज तो होना ही चाहिए. दिस इज व्हाट इट इज. सो एम आई क्लियर विद द प्रॉब्लम स्टेटमेंट? जस्ट गिव मी अ क्विक yes or no. Give me a quick yes or no if this thing is clear. Okay, fair enough. चलो आगे बढ़ते हैं. We are clear. Now let's see. Okay, basically suppose there are three courses. Okay, so if I want to sell three courses, like I want to see what are the ways to sell three courses. Ways to sell three courses. What are the number of ways I can sell three courses? The very first one is that I would only sell three. The very second one is that I would only sell two. Then the third one would be that I would sell two and three, two as well as three. Then the third one would be that I would be selling only the first one. Okay. And then the next one would be like, let's make the background as a matrix and let's increase this. Yes, C. Suppose there are three courses A, B, and C, and I want to know the number of ways I can sell three courses. Like I want to know, like what all ways I can sell ABC. The very first way is I would only sell C. Then I would say, like let's just say that whenever I'm selling a particular course, like first I would sell C. I would sell C, and rest all courses I won't sell. Then I would sell, then I would say that I would sell B, and rest of courses I won't sell. So 0 means no, I won't sell. Once means yes, I would sell. This is clear. The very next one can be that I would sell the second and the third course, but not the first course. The fourth one would be that I would sell the first course, but not the second and third course. Then the last one would be that I would sell the first course and the last course, but not the second course. And then I would say that I would sell the first course, second course, but not the third course. And the last one would be that I would sell the first course, second course, as well as the third course. These all way I can sell my courses of A, B, C. These are the only number of ways. These are the only different ways I can sell A, B, C. Am I clear to you? Just give me a quick yes. Yes, these are the only possible ways I can sell. And there is one more, that I won't sell anything. I won't sell anything. These are the total number of ways I can sell three courses. Ways to sell three courses. हम तीन कोर्स, अगर मेरे पास तीन कोर्स है तो उसको किस किस तरीके से हम लोग बेच सकते हैं. वन मीन्स वो पर्टिकुलर कोर्स बिक रहा है, जीरो मीन्स उस टाइम हम नहीं बेच रहे हैं. पहला है कि 001 मीन्स मैं थर्ड कोर्स ही बेचूंगा, ए और बी नहीं बेचूंगा. So am I clear with these always or not? Give me a quick yes or no. Give me a quick yes. Okay. Yes, absolutely. I'm clear. So now see, okay. So number of ways to sell three items. This is basically this thing is the binary. Let us show you a magic. This is the binary representation of 1. This is the binary representation of 2. This is the binary representation of 3. This is the binary representation of 4. This is the binary this is the binary representation of 6. This is the binary representation of 7. And this is the binary representation of 0. So to be honest, this value should have been on the top. Okay. So basically, to sell three items, we can just iterate from 0 till the value of 2 to the power n minus 1, and we can just use its binary representation to get the number of ways I can sell all these items. And this whole thing is known as power set. Let me just remove the background now. This whole thing is known as power set. So if you don't know about this, please go out and learn about this. This is a very important technique that you need to understand. Okay. So now here I have n courses. Here I have n courses. This means that I need to iterate from 0 till 2 to the power n minus 1. Like there, the number of ways to sell n courses are 0 till 2 to the power n minus 1. So let's just go back and see the value of n. N's value is only till 15. Okay. So we need to iterate from 0. So earlier the formula was that if I want to find out the number of ways to sell n items, we need to iterate from 0 till the value of 2 to the power n minus 1. Here the value of n is maximum 15. So in the worst scenario, we need to iterate from 0 till the value of 2 to the power 15 minus 1. Let's see the value of 2 to the power 15. 2 to the power 15 is 32768. 32768 minus 1, and that would be 0 till 32767. So we just need to iterate approximately 4 multiplied by 10 to the power 4. Approximation. Okay. So we can just replace this with this. And in the worst scenario, we just taking the upper bound. Okay, in the worst scenario, we need to iterate only this. And this is definitely less than 10 to the power 8. This is definitely less than, sorry about that. This is definitely less than 10 to the power 8. So we are good to go with this. So we can use this way, and we can see that if we, out of any of the ways of selling the course, like what we can do is, like we can iterate over all the ways to sell n courses. So we would iterate on all ways to sell n courses, and out of them we would return the minimum one. And how to iterate on L courses, ways to sell n courses? We would just iterate from 0 till the value of 2 to the power n minus 1. We would use its binary representation, and that would be done. So the takeaway from this is, whenever the particular range is less than 20, we can think of recursion, we can think of backtracking, we can think of power set. The takeaway from this question is that you can learn from this question. So am I clear with all of this? Can I move to the implementation? Give me a quick yes or no. What is the importance of 10 to the power 8? Basically, the compilers, like the online compilers, in 1 second process 10 to the power 8 operation. So if the number of operation you are doing is less than 10 to the power 8, then definitely you would be able to surpass, like the my given limit is to speak 4 hours, and if I speak less than equal to 4 hours, then I'm good to go, and if I speak more than 4 hours, I'm not good to go. So in the same manner, if the given threshold is 10 to the power 8, so if I perform operation less than 10 to the power 8, then I won't be getting a time limit exceeded. How do we assign sold course to a student? Basically, we don't need to assign the sold course to a student. If we are selling the course, we can just take the amount of money spent on it, because we are concerned about the budget. We are concerned about the budget. Okay. How much code forces rating is sufficient for a Google coding interview? I think specialist or specialist as well as a constant expert is sufficient enough in my point of view, but it is not absolutely necessary, because there are many people who have never seen a face of code forces or something, but still they are in a very good place like Google. Okay, so I think we can move forward. Share the screen, and will the student pass? And we are good to go. So, can I start writing? I think I can start writing. Okay. So, this is clear. But one thing I would do is that I would make this as the lowercase a. Okay. Now I would say that till how many, like we need to iterate from 0 till 10 to the power 2 and minus 1. So we would say that at what, till what point we need to move forward. Like what is the limit? Okay, pow. Okay, we would pow 2 to the power n. Pow 2 to the power n. Okay, we need to iterate till less than limit. Okay, so now we would say for int I is equals to 0, we would start from 0 and we would go less than limit and I plus plus. Okay, and initially the price, we are like the budget, like the amount spent is less than amount spent is 0 in this condition. Okay, first we would say that vector int of 10, okay, is equals to m course, n students. Okay, like there are m students, and each student is assigned with no course. Each student is assigned with no course up till now. Then we would start the iteration. Okay, like we would check each bit. So at max, the number of bit is n. Okay, so for int j is equals to 0, we would take the jth bit, we would go less than equal to the nth bit, and j plus plus. Okay, let's say, suppose the given value is 3. So if the value is 3, like let's take the value 6. If the value is 6, then its binary representation is 4 plus 2. So 1, 1, 0. This is the binary representation. So we would go from 0. This is for the first child, this is for the second child, and this is for the third child. Okay. So we would say if current I, if current I and, okay, and 1 left shift by j. What do we mean by this? Okay, 1 left shift by j. So if I want to check if the second bit is turned on or not, we would shift everything by 1. Left shift by 1. So left shift 110, 110, left shift by 1 would make it 10, because everything is shifted by one place. Okay, this is the meaning of left shift. After left shifting, we are just checking the value. If the particular bit is set, then that course is to be bought. So we would say amount plus is equals to P of J. Okay, the particular value of P of J. Like we are buying that course, P of J is to be assigned. And then we would say for int k is equals to 0 for all the other child and k plus plus. Okay, fair enough. And we would say temp of k plus equals to a of j dash k. Like if we are buying the jth course, then all students would get the benefit out of it. If suppose it is told that, let's see, suppose it is told that we need to buy the second course, we need to buy the second course, then each student would be getting the benefit of second course. So we are adding the benefit of second course to each one. Okay, then what we would do is we would come here and we would say bool OK is equals to the value true. First we would simply assign the OK value with true. Okay, so after that int j is equals to 0. Now we would check the knowledge of each student. First we have given everything, like the knowledge obtained by each student. Then we would check that the knowledge obtained by each student is sufficient enough or not. So we would iterate from j is less than m and j plus plus. So if the particular person temp of j, it has less knowledge than x, it has less knowledge than x, then OK would be false, like there is no point in moving forward, and we would break from this point. Like even if one person is not able to get the knowledge, then there is no point in moving forward, because every person needs to get a knowledge of a value x or more than x. Okay, fair enough. And after doing this, if every person is able to get a knowledge of x or greater than x, then answer would be minimum of whatever was already there and the amount we are spending. Okay, at the end, okay, at the end, okay, initially amount would be, let's say, amount plus equals to, okay, so int answer is equals to, let's say, 1e8. Let's take a very large value. After doing all this, if even after all this, if answer is equals to 1e8, 1e8, then we would return -1. But yes, this is not possible. Earlier it was 1e8 and still it is 1e8. That means there is no way we can do this. Else, if there is a way, then we would simply return the answer. Okay, accepted primary operation before break. It is done. So now tell me the line number at which you are not able to understand. Tell me the line number. This is the code. Tell me the line number at which you are not able to understand. Let me go here. Okay. Yeah, this is fine. So tell me the line number at which you are not able to understand. Sir, so how much, so clear what I do. So quickly tell me, yes. So quickly tell me one. Sir, can you take a test case and explain? Okay, sure enough. So test case, let's say that we have 3 courses. Then the number of ways to sell it is 001. Okay, like the number. So if there are three courses, then we would iterate from 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so first we would go to 0. In 0, the binary representation is 0 only. So no bit is set. So nothing would get added. Okay, so let's talk about 1. Okay, if the value is 1, then we would sell the first course. If we are selling the first course, that if the bit is set, we are just iterating over the bits. So this is the first bit. If this bit is set, then we would add the price of that course, because 1 means what, that we would buy this course. If we are buying this course, then that price, suppose there is a brinjal of 5 rupees. So if I'm buying brinjal, that means I'm spending 5 rupees. So I'm spending the value of the course. Then what I'm doing is that from that course each student would learn. So I am adding all the knowledge of this particular K, that knowledge of the course, to every student. So if I'm buying the first course, then every student would get the benefit of the first course. No? So this J is equals to 1. Let's say J is equals to 1 and K is equals to 0 to M. So first course, J is constant and only K is changing. The benefit of the first student from the first course, the benefit of the second student from the first course, the benefit of the third student from the first course. This is how we are doing. After that, we are saying that if every student has a knowledge greater than X or not, if any of the student has still a knowledge less than X, then this condition is broken. If even after this every student has a knowledge of X, that means this condition was never there. Then we would assign it with a value, and at the end we would return the answer. Now am I clear? Sure enough, Bernard. Okay, so am I clear? So what do I do after completing Java to get an internship? Learn about Spring Boot and all. Learn about learn about Java web development. When reading the problem statement, how do you interpret if we buy a course that it is shared between our student? Okay, so basically it should be given in the problem that if a single course is bought, then every student would get the benefit. This should be written, to be honest. But the very next thing is that here it is not told. Okay, so I can't really say. Pavni Khanna, okay, fair enough. So basically, here we are finding out. So let's just copy this. Line number what? Line number 74. Which is line number 74? Sorry. Line number 74 is this one. Let's copy this. Okay. So see, what we are doing is, suppose the given value is 110. This is the value of 6. Okay. So how we are checking if the particular bit is set or not? So what we are doing is that, see, to check the first bit, to check the first bit is set or not, we are doing a AND operation with 0, 0, 0, 1 here. Okay, and that would bring me 0, 0, 0, 0, and that is bringing me 0. So to check the first bit if it is set or not, I would simply do 1 at this point and with 1 at this point. If I want to check the second bit, then I need to do a AND at this point, and rest everything would be 0. If I want to check the third bit, I need to do a AND with this thing. If I want to check the fourth bit, I need to do a AND with this one. So basically, what is this? This is nothing but 1. Let me write it in yellow. This is nothing but 1 left shift 0. This is nothing but 1 left shift 1. This is nothing but 1 left shift 2. This is nothing but 1 left shift 3. Okay. So what I can do is, if I want to check the first bit, I would just do AND with 1 left shift 0. If I want to check the second bit, I would just do 1 left shift by 1. If I want to check the third bit, 1 left shift by 2. If I want to check the fourth bit, I would just do 1 left shift by 3. So I can say that if I want to check the ith bit, if I want to check the ith bit, I would just simply say the particular number, do an AND with 1 left shift by I minus 1. If I do a AND with this, it would tell me that if the particular bit is set or not. That is why in here we are telling I AND with 1 left shift J. This is the meaning and the internal meaning of this. So, am I clear to you, Pavni Khanna? Just give me a quick yes or no. Anyone else who has any issues, I would go to the very bottom and explain you so that you take away something from this. Sir, is it easy to code? Is it easy to code this in Java too, or will it get TLE? No, it won't get TLE. It is easy to code in Java also. Clear? So this was an explicit explanation for you, so I deserve a chocolate from you. Okay, let's move forward. So this is the last problem, and this problem statement is, to be honest, a little bit easy. Okay, the problem statement is easy, but the solution is a little bit on the hard side. Okay, so now see. Okay, so the given array is of size n. So we need to count the total number of subarray. What is subarray? So basically, subarray is a contiguous part of the array. A subarray is nothing but a contiguous part of the array. So if the given array is 1, 2, 3, 4, 5, then the subarray is, subarray can be this also, subarray can be this also, subarray can be this also, subarray can be this also. This can also be a subarray, but this as well as this can't be a subarray. So a contiguous part of the array is known as subarray. Am I clear to you? Give me a quick one. Now I need to count the total number of subways with bitwise and equal to the given value x. Okay, so 262. So let's talk about the very first one. There is a single element 2, so the bitwise AND is 2. So next it is telling me that 2 and 6 has a bitwise AND of 2. Let us see this. So binary representation of 2 is 1 0 and binary representation of 6 is 1, like this. So it would be 1 and 0 is equals to 0, 1 1 1 0. So yes, the binary representation is 2. So AND is 2. So yes, this is correct. Then it is telling me that 262. 262 is again like this. So this is again 0, 1 and 0. So this is again 2. This is also correct. And then it is telling me 6 and 2. 6 and 2. So 1, 1, 0 and 1, 0 is equals to again 2. Again 2. Then singular 2 is again this. Okay. That is why this is telling me that there are 5 subarrays with the total and as 2 itself. Count the total number of subarrays which equal to the and the given value x. So am I clear with the problem statement? I love to code with Python. Okay. So basically I love to code because if I'm explaining in the online forum, I am explaining it in C++. I'm coding it in C++. If I'm doing it on all by myself, then C++ only. If I'm taking batches, then I need to explicitly code in Java also. If I am coding in the office, then it's different language. So in a day, I code in approximately three languages. So I can't really take a side of a single language. The one square solution would be to check all subarrays right. Yes, absolutely. The one square subarrays, but a little bit of a little bit of modification to that would be enough. Okay. So now see, if you just see this problem, let me just close all this because this is done. Okay. So let's close all this and let's discuss about this. Okay. So now see, suppose the given value is a1, a2, a3, a4, and a5. Okay. So I can say that if this has a and with 1, then this can have a and with 1 also, and this can also have an and with 1. But if some point and with 1 is like 0, then this is not possible, because the given value x is never equal to the value 1, like it is never 0. Okay, given value x is never 0. So if suppose the and of a1 is equals to x, okay, or greater than x, let's suppose it is greater than equal to x, then we come to this point also. Again, suppose it is greater than or equal to x, we come at this point also. So we keep going until we reach a condition where it is equal to 0. And if we have a1, a2, a3, okay, like a1 is also, so this everyone has a and with a value x, so the value added to be answer is 3. How? So if a1 is also an answer, a2 is also an answer, so what I can do is, I can, the simpler brute force approach would be a1, a2, a3, a4, and a5. So I can say that if this value is equals and of this value is equals to x, good enough. And of these two values equal to x, good enough. And of these two values also equal to x, good enough. If suppose and of this value is equals to 0, then suppose we have 1 1 0 1 1 0 1 1 0, at this point if we have 0, then whatever this value is, even if everything is 1, the and of this thing would be 0 0 0 only. So whenever we reach a point which is equal to 0, which makes the and equal to 0, we would stop at that. This is the stopping condition. Okay, because in and every value needs to be present, like in an and. So if I want the and to be 1, then suppose there are three values. So every value needs to be 1 to get the and, to get the resultant and as 1. To get the resultant and as 1, we need every values to be 1. That is why whenever we reach a condition which is equal to 0, like the and of this would make it 0, we would say that this is not possible. Okay, this is what we are gonna do, and that would be a cunning approach to this problem. So am I clear? Like whenever we reach a 0 point, we would simply say that this is not possible. Okay, so what we can do is, the simple, very simple answer would be long answer is equals to 0, and then we would start iterating over the array itself. For int I is equals to 0, I is less than n, and I plus plus. Simple enough. And then we would say initially the answer is equals to a of I. Okay, because the and of a single element is that value only, and of 2 is 2 only, and of 4 is 4 only. So as of now the and is equals to a. Then from I we would move forward. So for int j is equals to I plus 1, j is less than n, and j plus plus. Okay, so we would first we have two. Suppose we have 2, 3, 4. So we come across 2, and then from j we are iterating over the rest over elements on the right hand side. Okay, so we would iterating over the rest of elements. So initially the and is 2. Now the next one, the and would be 2 and 3. Then the and of 2 and 3 and 4. We would keep moving forward. So we would say that res is equal to res and a of j. After all this, if still the res is equal to the value that is given x, we would increase the value of the answer. If it becomes 0, else if res becomes 0, then whatever be on the right hand side, the value would become 0. This is the cutting position. This is the zeroth position. At this point, whatever is on the right hand side, that won't make a difference. These all values won't make a difference. The answer is still 0. Okay, these all values won't make a difference. The answer is still 0. So we would say if the value of res is equals to 0, we would break from that condition. There is no point in moving forward. Okay, and then we are done. At the end we would just return the answer. Okay, long int res is equal to a of n, a of I, j is equals to j. So anywhere I have misspelled a value or what? And is equal res is equals to res, and then if res is equals to the given value x, then answer plus plus. Else if res is becomes 0, then we would break from this. Okay, we are breaking from this. Again we are making res as 1. Okay, seems correct. Let us submit this again. Done. Okay, so now do you have any queries to this or not? So I would just share the Chrome tab. Okay, this approach is still on square in the worst case, right? Yes, this is still, and in the worst scenario, this is still on square. If the test cases were 2, 2, 2, 2, 2, and x is also 2, then the time complexity would be very huge. Okay, if all the values, if and the value of all the array is 2 and x is also 2, then the time complexity would give you an on square, and this would result in TLE. But due to weak test cases, I found a loophole in this. Okay, now the very next thing is that how to do this. Okay, why it's not getting TLE? It's not getting TLE because of weak test cases. So you can just write weak test cases, okay, for the question, and this would be there. So that was it for today. So any more further queries you have, you can ask for the next 1 minute, and then I would be turning off this session. If you have any queries, you can ask in the next 1 minute, and then you can just do it. Any other approach to solve this? Yes, there is one more approach to solve this, that is using prefix sum. So you can just check if till this point to this point is equal to the and or not. Basically, you would just add the and of the bitwise operation, and you can do this bitwise and of all this. Is this the most optimized approach? No, this is not the most optimized approach. This is an O square solution, but due to weak test cases, we are getting an AC. So let's take the advantage of that. I have done with prefix sum, but getting error. Debug a solution on your end. If still you need a help and you are finding no one to help you, then you can ask me on LinkedIn. What is the time complexity of the prefix sum approach? The time complexity of the prefix sum approach would be n multiplied by 32. Okay. Any more? N multiplied by 32. Yeah, n multiplied by 32 would be the one. Which language do you use at work? I mainly work in the authorization part of Geeks for Geeks. So I code with like all the internal tech stack that is being used. So I can't really tell you the names, but backend is the one that I work at Geeks for Geeks authorization team. Which language? Okay, that's it for today. Thank you and have a nice day. So, if you are watching this stream in the recorded version, feel free to like and comment the video so the reach of this video could be increased. And you can give your views like what all modifications you want in the next contest. So, hopefully, they would change this. Thanks a lot. So, if you liked my explanation, there was a lot of hate that I was going undergoing in the last stream. So, if possible, if you like if possible and you were able to gain something out of this explanation, then you can just give me a feedback. How would you rate the level of this contest? If the test cases were not weak for the last problem, then this contest seemed like a code forces contest. Okay, like div 2 of code forces. Why? Because the problem statements were lengthy. And the last problem seemed like the problem statement of atcoder, because in atcoder we have very simple problem without any storyline or something. Most welcome Shruti, most welcome Shivam Chaurasia. But I can say a little bit of poor explanation was done on the problem statements. And to be honest, what happens is the problem setters are the ones who are just writing the problem and just moving away. But I am the one who is sitting on the front desk. So if someone on the back end is doing some problems, then I need to take the heat because I'm not the problem setter. I didn't do anything. If the problem is complicated, if the problem is very poor, then I can't give a I can't give a awesome explanation to a poor problem, if you understand. Okay, so I can't give that. So basically, I need to take all the heat to this. Okay, so I think that was it for today. Thank you and have a nice day.